Students, we are discussing the line coding techniques. और हमने ये डिस्कस किया था कि हमारे पास 5 basic categories हैं in which we divide these line coding techniques. Students, these 5 basic categories are unipolar, polar, bipolar, multi-level, and multi-transition. So let's start looking at these techniques, and we'll start with the unipolar non-return to zero. Students, as you can see on the slide, in this technique, line coding scheme or line coding technique, all the signal levels are on one side of the time axis. As you can see, the signal levels are either above or below this time axis. In this particular case, as you can see, we have got 2 levels. We've got a level V, and then we have got a level 0. There is no voltage levels that are below this time axis. Students, why is this called non-return to zero? The reason this is called is that the positive voltage defines 1 bit and the 0 voltage defines the bit 0. So you can see positive voltage is 1 and our negative voltage is 0. At no point in time, the signal returned to 0 in the middle of the bit. So you can see, for example, for this 1, throughout the bit, our signal stays at the positive voltage point. Similarly, for a 0, throughout the bit, our signal stays at the time axis or voltage 0. The signal does not return to 0, for example, in the middle of the bit, and therefore this is called as non-return to 0. Unipolar non-return to 0 scheme. Students, you'll see that in this particular scheme, the normalized power, the power that is needed to send 1 bit per unit of the line resistance is very high. In the further schemes that we are going to be talking about, the power that's required is low, way low than unipolar non-return to 0 scheme. And for this reason, this scheme is normally not used in data communication anymore, but is the most basic of the line coding schemes that we have, and this is important to understand this scheme, to understand further schemes that we're going to be talking about, which are further and much more advanced in nature. Students, moving on to the polar schemes. As you can see in the polar schemes, there are 2 subtypes of the polar schemes, by the way. There is non-return to 0 level, and then we have got non-return to 0 invert. But in both these cases, the primary commonality is that we are now using voltages which are on both sides of the time axis. You can see that the voltage level for a 0 is a positive voltage, and as soon as we switch to 1, the voltage level returns to negative. So we are essentially using 2 voltage levels, one of them above the time axis and the second one below the time axis. Now students, in this particular case, it is non-return to 0 once again, because we are not making the transition in the middle of the bit once again. We have 2 versions of polar NRZ, non-return to 0. It is NRZ L and I, and L stands for level, and as I told you, I stands for invert. In the NRZ level, the level of the voltage determines the value of the bit. In the second variant of this polar NRZ scheme, which is NRZ invert, the change or lack of change in the level of voltages, that determines the value of the bit. Students, in the first one, as I told you, we have got assigned levels NRZL. We have got assigned levels for 0s and 1s. We have got a positive voltage for 0. We have got a negative voltage for 1. As soon as we move from 0 to 1, the voltage changes from positive to negative. It stays constant because it's NRZ. As soon as it changes again to 0, we go back to positive. The next bit is 0, it stays positive. Next bit is 1, it comes again to the negative voltage level. Once again, we have got 1, it stays the same. 1, it stays the same. And then it's 0, so it changes, its voltage goes to positive 1. This is our non-return to 0 level. Students, the non-return to 0 invert, the change or lack of change in the level of the voltage, in this case, it determines the value of the bit. If there is no change, the next bit is 0. Now this is important. If there is no change, the next bit is 0. And if there is a change, the next bit is 1. So students, our first bit is 0. And there is a change. So the next bit is 1. Then we have got a 0. There is no change. There is 0 again, no change. The next bit is 1, we change to the positive level. Next bit is 1 again, there is a change again. Next bit is 1 again, there is another change. Next bit is 0, no change, this stays the same. So in this particular case, what's happening is that a change in level represents a 1 bit, and if there is no change, it represents the bit 0.